Hello everyone, welcome back to this channel. In today's lesson, we are going to solve an example on fluid in rigid motion, specifically acceleration on a straight path. And this is a question we are going to solve. And the question reads, a 60 centimeter high, 40 centimeter diameter cylindrical water tank is being transported on a level road. The highest acceleration anticipated is 4 meters per second squared. Determine the allowable initial water height in the tank if no water is to spill on during acceleration. So this is the question we have here, and we have to find for the allowable initial height to avoid spillage. So in this question, there is no diagram, so we are supposed to produce our own diagram to aid us in solving the question easier. So this is how the diagram is going to be. So this is our container. And let's say this is our road here. And we have something like this. Yeah. And they gave us the height to be 60 centimeters. So 60 centimeters. And we have the diameter of the container to be equal to 40 centimeters. So now there are certain things we are to identify on the diagram. So we have this here, this dashes here. So we are trying to say that this is the maximum height it's supposed to reach to avoid spillage. So if it gets to this height, after this height, there will be spillage. So let's name this side theta z or delta z here, and let's give this angle to be theta, and this is our h max. That's our maximum height we want. That's from this side to this side. So in order to get the maximum height, we have to find for delta z here. And we were also given the acceleration along the x-axis, so we can name it ax to be equal to 4 meters per second squared. So it's moving along the x-axis. It means we can assume that there is no vertical acceleration. So it means az, or the vertical acceleration, is going to be 0 meters per second squared. So it means the only acceleration that will occur at the vertical section is going to be the gravity. That is going to be 9.81 meters per second squared. So that's the only acceleration that is going to occur there. So now, to solve the question, we would like to find for the delta z first. And the delta z, we can find it by finding our theta here. So our theta here, so we can use the tan theta to be equal to ax over az plus g, where the ax is going to be our horizontal acceleration and the ac plus g is going to be our vertical acceleration. It means the acceleration here and also the vertical acceleration at this side. So in solving for this, computing for that, we are going to get 4 over uh, 9.81 plus 0, which is going to give us 0.4077. So that's tan theta is equal to 0.4077. So that means our theta is going to be equal to the tan inverse of that. So 22.18 degrees. So we have this as our theta. So what's next for us to find for? We are supposed to find for our delta z so that we can calculate for our maximum allowable height, which we're supposed to find here. So in finding for this, since we can assume since this cuts the mid plane here, we can assume that the free surface above is relative to the mid plane here. So we can use that assumption to find for that. So we know that the mid plane, the diameter for the whole container is 40. So at the mid plane, it is going to be 20. So we can guess our delta z to be equal to the half of it, that's the mid plane area, multiplied by the tan theta of that. So in this, we can compute our delta z to be equal to 40 over 2 times 0.4077. And our delta z, after the computation, is going to give us 8.14 8.154 centimeters. Since we worked with a 40 here, we didn't convert it, so it will be in centimeters here. So now we have to find for the maximum. Now we can find for our maximum, or yes, we can find for our maximum initial water height. That's going to be H max is going to be equal to the H here, the H we have here, which is the H of the tank, minus the delta Z that we had. So H max is going to be equal to 60 minus 8.154. So our H max is going to be 51.85 centimeters. So it means this is the maximum or the allowable initial water height we have to reach. So above that, the water or the liquid inside will spill out. So we are supposed to maintain this height. Otherwise, there will be spillage with this using this acceleration that we have here. So this is how we go about this type of question, or this is how we go about solving acceleration on a straight path.